So identify handshake failures. That's something we did that, right? We tried to connect to 8.8.8 over port 80 and the handshake failed. I sent a I sent a SYN, but I didn't get a SYNAC back. So the service is refusing. 8.8.8 is refusing the connection over port 80, but it is good with port 443. So what is the TCP packet structure we discussed? What is the TCP sequence number and what is TCP acknowledgement number and where do we see the retransmission behavior? So here it's about detecting the packet loss and selective acknowledgement usage. That's something we are not doing today. If we have time, yeah, definitely we can do it. But now let's focus on the actual resets. When we do the actual reset, how it looks. So now we saw that the reset, we understood that reset is different from the actual reset. When I say actual reset, if there is no service running and if it refuses the connection, how it looks, how you can differentiate that in Wireshark. Yeah. So let me go back to this lab and the actual reset is something we can replicate it. Let me go to terminal. Let me go to lab switch here. That's in this guy in the middle, lab switch. So run section VDY transport input telnet. Okay. Um, I do a putty? Maybe I will download a putty quickly here. Okay, so let me try to connect this with telnet. I just want to see because it uses a TCP. Okay, so first let me ping this guy 122.60 from this device. Ping. See, we got this VLAN, I think VLAN 900, VLAN 999. That's used for the external internet traffic. So I'm trying to ping this guy from this Windows device directly connected. Ping 122.160.50.60. I can ping. So I'm trying to establish a connection with this. Let me start my capture. Now I'm giving IP dot address. One 122.160.50.60. Conversation filter TCP. Sorry, I mean, we'll try one more time. 122.160.50.60. I'm doing a telnet. I give Cisco enable password, no password set. Let me go to the switch. And now go run section line VTY0. Let me go to this line VTY 024 and I'm doing transport input SSH, no transport input telnet, no such command for it. Put transport input SSH and not telnet. Okay. So now let's go back here. Try to do new session. Other, the IP address would be 122.160.50.16. What do we see here? So I'm going to the expert info here. Okay. So if I go to conversation filter, TCP, see, I have sent a SYN, but there is no telnet service running on the switch. And immediately, who sent this reset? Look at the source 122.160.50.0. Again, look at this. There's so many people I have seen they tripped off with this. The source is 120.160.50.65. This is my computer, yeah. Back to my connection, I'll show you IP config all. So most of them ask me this question. I mean, how do I find who is sending the reset? That's something I'm confused of. It's very simple. So I'm sending this SYN packet 122.160. You can compare this in the top right source 122.160.50.65. This is sending to the destination 122.160.50.60. That's a switch IP address it sends. And who is sending a reset? 50.60. Do I have 120.60? Sorry, 50.60. I don't own this IP address. 60 is owned by this switch. Show you that. Show IP interface brief. 122.160.50.60. So this is how you should differentiate. This reset is different from the reset what we discussed before. So it is thinking that I can't reach this. See, now the reset gone and now it is with the TCP timer started, the communication is not happening and it is trying to do a retransmission. Again, for this retransmission, the third packet, for the first packet, you got a reset and after a specific time period, it does a retransmission. It tries to reach a destination over the port 23. But again, I get the same reset from this guy. So can I conclude that this is something it's being blocked? No, I don't see that. It's something blocked. This is something, it's a reset. The destination doesn't have the service running. What are the two possibilities we get here? The export info, it says that it's connection reset. You have to ask them a question also. You have to check, is it in your firewall or in your switch? Are you blocking it? Are they blocking it? But here, when you concluded that your firewall rules are clean and you are not blocking anything, it's them. As I said, with this output, you know the peer-to-peer communication. You don't know what is configured in the middle. But I can say, if you draw a line like this is your firewall, this is your switch. It can be a layer 3 device, it can be a firewall, load balancer, whatever you have here. A layer 3 device, it does a routing. The the one which we have colored with green is us. This is someone else. Yeah, for us it's a strange connection, or maybe I would say this is not owned by us. So this is our territory. So here we can say that we are not blocking anything because you checked everything. You can confidently go ahead and tell them that we are not blocking anything. We have verified all the rules. This reset is coming from the destination. This is you. You have to check, are you blocking this traffic? Or are you really running this service? That's how you should logically you should think about. Who is doing a reset is very important to figure out. Okay, now let's see how the sequence number and acknowledgement number works with the same example. For this, let me go to this switch. Yeah. So run section line VTY. So now I'm going to enable this line VTY024 transport input telnet. So now going to this machine, going to run the capture again. And before that, I have to set the credential for it. Show one user config line VTY024 password Cisco set. Go back to this Windows machine on the putty to the telnet IP address 122, same destination 160.50.60. Step 1, step 2, run the capture, open the capture. Once you see the traffic, try to establish a connection with the password. How come still it can say that I didn't assign the password? Show run sections. Line VTY024 login, right? Login. Let me try one more time. One 122.160.50.60. Let's go. Let's go. What is that? I'm doing something wrong. Section. So that's something I have to find for VRS. I'm telling login local transport input SSH. It's simple. I think it's a lot password line VT1. Is it just a login? Be using that user. There's an option to get the privilege, right? Privilege 1115. Password. Let's go. Because of this, you'll get same error. And VTY 024. Give login local. Seriously, I mean, okay. What? Enable password is something we keep it, right? Oh, what? Long back. I did this command. I think it should work now. Gave Cisco. Is it? I didn't set any other password other than Cisco. Just give me trouble. Doesn't have any privilege. Level 15. Let's go. Let's see. Okay. I have to give a privilege on the enable password. Fine. Let's do a capture again. So I want to do it for my control. Place a filter selected. Yep. I want to make this IP dot address equal E50.60 to get a connection back now. Duplicate the session, enable, logged in, config, something I'm changing, host name, same, just to send some data. Done, and if I exit the connection, stop this capture, go to the top, finding this. So you see this is a then I got a Synac back. So I see this. If you look at this from here, right? So you don't see any kind of data. So from here, it established a connection. So it starts with the sequence number 13, right? And I'll show you that. Go to transmission protocol. You see the sequence number and acknowledgement number. So right over here, if you look at this, and it's telling that the next sequence number, the next data, what the client is going to send, right? It's 573. This 122.60.50.0 is telling this, right? So it is sending 13 bytes of data here. Then the next sequence number, it is telling that say from 13 to 153, it's advancing. This is the actual payload happening between source and destination. And if you look at here, the sequence number, you don't see any kind of traffic right over here. And it is keep advancing your data. If you come down, drill down, if you want to see the actual amount of data which has been sent so far, it's 1106 bytes of data. And here you see this fin packet here. Whenever you see, if you want to see your amount, the data, what you're trying to send, and if it is properly reaching the destination, there is no packet loss. So this is a clean capture, and this is how it looks. And let's see, let's try to do something. This is for a telnet. As I said, this is how the sequence number and acknowledgement number works. Yeah, see this guy, he sends 573 bytes of data he received, and see he's acknowledging this 630 bytes of data. If you add this together, 614 plus 111, so it will come close to the 630 bytes of data altogether. So it acknowledging, so far here it got all the packets back, right? But it is acknowledging again, and it keeps sending the data. And if you drill down, as I said, if you go to the bottom of the page, you will see the amount of data what it has sent so far. The other field where I will check for this, you have to go to statistics, conversation, TCP. So you can see this. So this communication is happening between the port 23 and 50195. So this is a client, right? This 60 is a server. And A to B, this amount of data it has been sent. And if you want, this is for TCP conversation, I'm telling the three-way handshakes you can see here. And in the IPv4, you can see all the communication. See, This is all something it was talking to a different destination. And if you want to limit your filter only to this particular source and destination, you can click on the limit filter. And right away, Wireshark, what it does, it will apply the filter for you. And if you want to capture only the telnet traffic, you can give telnet. And once you see that, the very first thing you have to do is go to any packet, do right click, conversation filter, and TCP. So that takes you right from your SYN, SYNAC, ACK in your beginning of your traffic and the end of your communication. You can see the traffic sequentially like this. So now we have seen this is the amount of data we have sent. This is very minimal because this is a telnet. We'll do the same thing for 8.8.8 and we'll see what is the sequence number and acknowledgement number, how it is advancing. So let's open the capture, go to Ethernet, IP.address 8.8.8. Let me do something inside. Let me query for Yahoo. And then this is purely DNS. I think we should see only the DNS. I don't think we can see any TLS traffic. But to generate some good amount of traffic, we try to open something. Let's try to open in map website. So this is a destination. Let me go to the right click conversation filter TCP. So if you can't find it, so how do you filter the only the TCP packet? Even if you don't know that, if you click on this, uh, it's in the preferences. No, it's in the view coloring rules. We go here, you can see the filters here. For the reset, if you want to see the reset, tcp.flags.reset equal 1. The same way, I will open my capture. I think I have it with me. View. Let me go to view coloring rules, tcp.flags.syn equal 1. That's the same rule. We are going to do it here. So I'm going to click on this. New coloring rule. I'm going to name this as TCP make this as a TCP SYN coloring rule. I'm going to apply a filter TCP. It's automatically it generates the filter for you. Flags.syn equal 1. So this is very helpful for you to filter your packet because all your conversations should start with this. So if I do that, I give TCP dot flags dot syn equal 1. See, look at this for the SYN packets for all this, from this is a source and destination, right? I didn't get anything packet here. Right click, conversation filter, TCP. See, after this, we got SYN, we got a redirect, and we got a SYNAC back. Okay, we got it here. And one more thing I missed to say, if you go to go to view coloring rules, and you can give a color to this. Uh, One minute, I want to do it for a background. Give a background color green. That's something I would prefer always to say it's successful. View coloring rules. TCP.flags.syn one. Yeah. Okay. So now if you see this SYN, SYNAC, all the flags with set with SYN, you're going to see that. So this is the first packet for this conversation. So it started with what sequence number 1461. So it is advancing the packets. See, look at this 518. For this 518 bytes of data, you get an acknowledgement here. See, it is telling that send me 518 bytes of data, and it is sending it. And this guy is acknowledging. Who is acknowledging? 50116.1.184. Destination is acknowledging this 518 bytes of data which the client has sent. And one more thing, what you should think of is, see, this guy is requesting for the next sequence number 644, and he sends 644. Sometimes it is a straightforward. We don't want to go really deep about this, but what I'm telling is you should understand the mechanism of how this packet is being exchanged between source and destination, and how this in, what is the sequence number and acknowledgement number, how it works. And you can see here, see, your conversation is happening in the middle. You see the reset. See, as I said, see, it resets the connection. Then again, you see the fin packet. It doesn't mean that your connection is terminated. So it is done with the conversation. How do you check that? You should always see your fin packet. So totally, see, look at here, 24,259 bytes of data. And still, there is some data has been exchanged, and finally, it is 25,715 bytes of data. So why I'm going too deep about this is because this is very essential to understand your three-way handshake and how this actual payload communication is happening. And on top of this, what if this particular packet is lost in the middle, and how the Wireshark is going to, what is the mechanism used by the Wireshark to get the packets back? How do it queries for the lost packets? That's something we'll discuss in the next class. That's all about, we discuss about the selective acknowledgements, duplicate acknowledgements, out of order packets. That's something, even advanced topics. But the very core fundamental, as I said, is three-way handshake, your four tuple connection, your TCP reset, then your push flag, then your fin flag, then sequence number and acknowledgement number. And how do you apply this as a filter? And how do you use this option? How do you make your own profile in your Wireshark layout? You can design. So it helps you to understand what exactly happening between source and destination. Now, without confusion, you will get a proper, clear picture of what's going on. So that's the whole point of today's class. So let me stop recording and let me start recording back again for Q&A session. Okay. So let me give an unmute permission. Yeah. You can ask your questions now.
Yeah, I have a doubt. Now, coming to the push packet,
Mhm.
is it depending upon the destination address or the application that we are trying to access? The push is initiated from the client side, or in what scenarios actually the push is initiated?
Sorry. Okay. That's actually a good question. For example, it depends. Okay. It's purely based on the application, how they design the application. But if you ask me why, what is the need of push? Without push, what happens? So it is something I would say if you know about QoS or
Yes.
maybe priority, you can take it a very simple example. Why do we want to go for QoS? You can take a very simple example as a priority. So if a client is sending a packet to the server, and if there is no push packet, it is not demanding anything. I mean, it is just telling that you can treat me normally.
Okay.
But if the application is designed and if the application is very sensitive, so most of the application is like that. I mean, it expects the reply very fast. So in that
Und
case, the client will set the push packet. It's purely based on application, as I said. And then
okay.
if it sends, even though it is processing other packets, it is telling that you have to, give a priority for me because I set the push and it is sending it back. Good.
Oh, okay, okay. It's basically so that we don't have any latency in between and don't want anybody to intrude when we have the peer-to-peer connection. Okay, got it.
Yeah, 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 right.
Thank you.
Yeah,
Thank you.
yeah, yeah, no problem. Yeah.
Hi, Praveen. Uh, in there, the conversation A to B and B to A. If my traffic is coming from A to B and B is not sending, then how to identify in that conversion?
But you mean in the, what is that?
TCP, there was a one option at TCP. We check the packet source and destination IP packet
You
data. So,
mean the IP conversation you're talking
yes,
about?
yes, yes, yes. Yeah, yeah. Conversation. Yeah, IP conversation. So sometimes the server is not replying to us in that condition. How to check over there?
Okay, then you can check your sequence number and acknowledgement number. I mean, for the packet example, 560 bytes of data has been sent. So do you get an acknowledgement back from the server? That's something I do if I want to see who is not sending the reply back or where, I mean, who is not sending the reply back or maybe where the packet is missing. I will quickly spot and I'll go check that.
Yeah,
Compare
yeah.
with sequence number, acknowledgement number.
As well as sometimes A to B's conversation is going on, but
Mhm.
intermediate issues happening or something is there happening between. Then how to identify in that IP conversation? So could you please share here?
One minute, I don't okay with the
Yeah.
sorry. Wait 1 second. I think it's recording, right? Let me open this. Yeah, with this, what is your question? Here?
Yeah, no, no, conversion option, na?
Okay. Statistic conversation. Yeah.
Yeah, here A to B is their packets and B to A again and A to B.
Yeah,
So
I will tell you, Vithal. I mean, don't look for this. Okay, this is something I shown you to see your four tuple connection is happening or not, and you see the pattern. But what generally I would do is come to this capture, and if you are telling that to who is not sending a reply back, it's example, say example here. I have sent, let's take the best example. Yeah, see, this guy, right? So this guy, he's sending this, he is asking that I need 518 bytes of data in the certificate exchange here. And this guy is sending back 5 8s, 518 bytes of data. And again, if you see 3328 bytes of data, it is asking. And this guy is sending back again. See, look at here, 3586 bytes of data. The server is asking, and this guy is giving back again. So from this, you can figure out who is not sending the acknowledge. I mean, what is that? The who is not sending the actual data? I mean, If he is not sending any kind of sequence number with the amount of bytes of data what he needs, and if he's not doing it, then we can figure out, right, why he is not acknowledging. So the very first moment, what happens if there is a connection, it's if the connection is broken. So this guy is going to send a duplicate acknowledgement for this guy. Example, this guy sent, this guy is asking for 8 bytes of data, correct? And if he is sending it, so you don't see any duplicate acknowledgement packets here. But if this guy is asking for 8 bytes of data, 18 bytes of data, and if this guy is not sending it, this again, this server, right? 50.116.1.184, he will send a duplicate acknowledgement for the previous packet, what he sent. You got it? What I'm saying? So if your connection is broken here, 2921, he asked 2921 bytes of data, correct? So this client asks for 2912 bytes of data. He acknowledged here, see, he is sending back again. The server is sending back again. And if I don't get it, he will send a duplicate acknowledgement for it. Then it means that, okay, the packet is not yet delivered. That's why he's sending a duplicate acknowledgement. That's how I'll figure out. That's how I do when there is a problem.
Okay. But my question is still then what we have to identify in the IP conversation?
IP conversation is just what do you say? The whole
Mm.
output, it proves that are you really sending a data and how much data it's been sent? What is your duration? If you see this, see, I'll tell you very simple logic. If there is no TCP handshake communication happening between source and destination, do you see this traffic is incrementing here? Do you see that traffic incrementing here?
Yeah.
No, that's a question. Can you see this packets incrementing here if there is no TCP handshake?
No, then in this the condition I having for example, A is my client and the B is my server. Okay, and if something is happening or something is data is stop or something is happening.
No, I
So
got it with all. I'll explain. I'll explain your question. But first, you tell me if there is no three-way handshake, can you see all this traffic here?
hmm.
It's again a question to you. Can you see this traffic if there is no three-way handshake? So what does it mean logically if you see the traffic? So it means that your connection is happening. So this is
Correct.
just an output to see, is it really my communication is happening and how much data has been exchanged, but you can't precisely find. As I said, if you want to see the precisely how much data has been sent, you have to go to the bottom of your page. It's totally 25,715 bytes of data that's been exchanged. That's how I do. That filter is just to see your 4 tuple connection. That's it. It doesn't give you much details. It just helps you to find, okay, my A destination source A B conversation is happening, or A B and B A conversation is something you can see there. That's it. See, you can see a packet from A to B is this address is A. Yeah, this address is B. A to B is happening. And if you see B to A, B to A is also is happening here, packets. So it means that my bidirectional communication is happening. That's just give you a sweet spot where you can find, but not very detailed like this here. That's just an option I told you to see your 4 tuple connection.
Can you check it on that red message and then conversation? Yeah. So
What
what
do
is
you
the
want
difference
this?
between that the working and the non working
I told you,
logs?
right? I told you, right? Do you remember? You tell me now. We will learn. I mean, what is the difference between this reset and the reset what I have shown you in the non-working scenario? What is your understanding? You tell me. We will learn from there. I'll clear your doubts. You will understand better, right? Instead of I am telling you straight away, maybe you will not get that satisfaction. You tell me. I mean, what is the difference? When I did a reset connection, I have shown you the scenario, the telnet, and what is the difference between that reset and this reset?
In there, the reset means the server is not responding.
Mhm. But why? What I didn't see there? Did you see the three-way handshake happening there?
The retest mission.
No, no, the three-way handshake. Did you see that the three-way handshake happening with that in the telnet conversation? What we are discussing about? Did you see that three-way handshake between client and server? No, it didn't happen. Right away, you saw this reset. But here you see this synac act. I see this three-way handshake happening. I see client hello, server hello, all this application traffic is happening. And finally, I see the reset. That's something I told you. When it is finishing the conversation, there is few reset. That's something you can ignore. We should not confuse with the actual reset. The actual reset is something I have shown you in the telnet. That is the difference between the actual reset and this is something you can ignore this reset when you're troubleshooting. Yeah.
Praveen, why in this scenario,
Mhm.
instead of a graceful close fin act, just before that, why do we reset it? I mean, why do we send the reset packet instead of a graceful closure of the connection?
That's what I'm telling. It's purely an application control. We have
Oh,
no
okay.
control with that. See, all you have to
Okay,
focus
okay.
on is do I see the fin packet or not?
Ah, right. Okay, okay, understood. Understood.
That's
Okay,
it.
okay.
Yeah.
Okay, depends on. I got
Yeah.
it. Thank you.
Yeah. No problem.
I
The point is, do you see this reset before the three-way handshake is a problem, but you see the reset here, not a problem.
Yeah, understood.
Yeah.
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 So, Praveen,
Yeah.
hello.
Miraj,
Yeah,
right?
so
Yeah.
here the reset with acknowledge means either the client or the server want to close the connection. Then the fin will be initiated, right?
Sorry. What is it? What is your question again?
The last one, reset with acknowledge, it means that either the client or the server want
No,
to
no, no.
close the
You
connection.
no. Here, the whole point of why we are training, we put a lot of effort is who is doing a reset here.
Yeah, so this reset is it means that the like for example the client want to close the connection because it is done. Then it
Yep.
will have a fin acknowledgement, right?
Absolutely. Yeah.
Yeah. So the other reset where with the three-way handshakes not done, that is the different scenario that
Correct.
the connection is closed.
Absolutely. Yes. You're
Okay.
right.
So the sequence number here is actually the payload, right? It is also give us the information about the payload, how much data is
Correct.
in, right?
Correct. Correct.
And the acknowledgement to this sequence number, will it be one number will be added or it will be the next
That is actually for an example. If you look at this, maybe it asks for 3,328 bytes of data, and it has sent, and it asks for 644, and it has sent, and this is 3584. I
Mhm.
think when you add up this, what you will get? 8
Okay.
plus 4, is it 12?
So
8
yeah.
and 12. Then the number is not matching here. That's just for the understanding. I mean, that's a one. The increment of one happens in the beginning, okay, and then it
Mhm.
depends on the number of payload. I don't know. We can't decide that level, right? Example, if your certificate handshake is happening, we don't know how much
Yeah.
amount of data it sends. But with
Mhm.
this, what I am telling is what we can focus and we is something okay. Who do I request for some bytes of data and do I get this data back? Is that happening or not?
Mhm.
See, this guy here,
Okay.
he asks for after this 10 conversation, you can say, he's asking for 8,449 bytes of data and he's sending back,
Okay.
right? So it depends. So sometimes it may add up everything and in one go also it will do an acknowledgement or for every single packet it will do an acknowledgement. It's purely depends on very deep level of how they designed the TCP.
Okay. So for sending during the data sending, uh, for one sending and responding to that sending, how much time it will be calculated? How can we see
Actually,
the time?
I
Like
don't
for
do
example,
that
I'm
level.
sending 1500 of data and I'm getting the acknowledgement for the next sequence number, right?
Okay, let's take that. Okay, let's take that. I sent, okay, this guy is asking for this, and it took 346 milliseconds to send us 644 bytes of data.
Okay, and the next sequence number for that,
Which one?
like it's asking for the next data.
Asking for the next data here, 1238, and he sent this 1238 here,
Hmm.
and he sent an acknowledgement for this 1238. He sent 1238 bytes of data. You can see this ACK field. Server sent an acknowledgement, right? Here, if you see 1238. Here you see this client sent 1238 and server is sending 1238 here. Can you see this? Here,
Yeah.
these two diagonally.
So suppose if the middle of the connections having delay, like for example, it's a database server and the
Mhm.
backend server initiating so many connections
Yeah, yeah,
to get the data.
correct.
So for one of the connection, if the database server is giving slow response
Mhm.
or not responding properly, so we will find out based on the time, right? So it's
No, no,
taking
no, no,
time.
no, 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 no. But that's something your client will send a duplicate acknowledgement. Your server will be busy with something, okay? And
Uh-huh.
the client will send a duplicate acknowledgement for it because it is asking for 6388 bytes of data, but that guy will not respond to that. So he
Uh-huh.
may think that, okay, that guy is dead or the server is not responding. So what happens, again, it will send a duplicate acknowledgement for the previous packet. Example, the previous packet is 4928. So it will keep sending the duplicate acknowledgement for 4928 bytes
Okay.
of data because
Uh,
it is expecting 6388, but still I didn't get an acknowledgement for 4928.
mhm.
Then it will
So if
do
you're
two pack for this particular sequence number 4928, two pack. Then
mhm.
again the server will recognize and it will send back again 6388 bytes of data because it's expecting 6388 bytes of data. And if it receives, yes. If not, then it will send a two packs. That's a scenario we'll do it. You'll understand better.
Okay,
But
okay,
that's
got it.
the whole idea of duplicate acknowledgement. When there is a
Mhm.
latency and if there is a packet loss, you see a lot of two packets.
Mhm.
I think when
Yeah,
I
yeah,
did,
got it.
yeah.
Thank you.
Praveen, now with respect to the acknowledgement, now I have got it out. Now we see that the server from the ACK field that you have, we can see that server is acknowledging it. But how do we see that the client is also acknowledging it? The amount of data, do we see anywhere? Or we see the ACK flag equal to 1 on this client side?
You're talking about this handshake in the beginning?
No, no. Marriage has asked it out, and you had clarified that we get the ACK from the server
Mm-hmm.
for the amount of data. So, is it similar in case of the client also? We can see that it has acknowledged that anything like that from
Yeah,
the
yeah,
client
yeah,
as well.
yeah. Yes, that's right. Yeah. See, this is a sequence where it's asking for, it sends an acknowledgement. See, basically, what I would say, yeah, I will open the slide. So that's why we have to go from the very minimum. See, you just forget about that. So
Okay.
this thing, the client is doing a send and it is telling that sequence number 100. Client
Yeah.
initiate with sequence number 100. So this sequence number 100, right? So it is telling that send me 200 and this acknowledgement is something, see, he's acknowledging for this packet. He added one.
Yes.
For this 100 bytes of data, he got it, he acknowledged, and he's telling that, okay, send me the other second sequence of 100. So 100, 100, 100, 300. We got 100, 100, 100. This 100 is the first packet, right?
Yeah.
He's sending.
Yes.
And this guy is acknowledging for this 100. Done. Now this 100 bytes of data, again, he's asking. So he's telling that sequence number 200. So it means that advance your packet. And this guy is sending, right? 200 bytes of data. This guy.
Yes.
And this guy will acknowledge back again. See, acknowledging 201 bytes of data. So he got the 200 bytes of data. Server acknowledges the client with 201. So what happens
Okay,
here?
and this
Data
sequence number
sent.
again depends upon the application, right?
Correct, correct. So he's
Uh,
acknowledging, say, 301. This is an example. So he got so
okay,
far 300 bytes of data. So if you want to send 300 bytes of data, at this point, he's acknowledging 3.1. So it means that he got all the 300 bytes of data. That's the whole meaning
okay.
of it. Yeah.
Okay, gosh.
Very good, guys. Very good. Amazing questions. You guys are learning sequence number and acknowledgement number, but I thought sequence number and acknowledgement number is actually very confusion part in the beginning. It's hard. I mean, in the beginning, it's really hard to understand this, how this sequence number and acknowledgement number works. It's good.
Praveen, can you give idea about the ECE, explicit congestion notification?
Yeah, sure. Yeah, I really appreciate your curious questions, Vita. Yeah, we have it. EC, ECN, explicit congestion notification, right? We'll discuss about that. We have that. Yeah, in the upcoming class.
Okay, thank you, Manish.
Yeah. Anything else, guys?
So today we
Okay.
have finished reset, finish, and push, right?
Yeah, correct.
In the urgent and the EC is pending, right?
Urgent,
Both.
mostly, I would say it's very hard to see urgent packets. I think it's deprecated. I don't see any more urgent packets. That's actually deprecated. You can give a try, but I think maybe very old capture, maybe the old TCP conversation might have. I don't think not I don't think, I mean, I don't see those urgent pointers being used now. Only push.
But again, it's depending upon the application, right?
Absolutely, but as I said, I don't think 99% of the applications are not using it. That's my research about that. Yeah,
Okay, no problem. Thank you.
no problem. Anything else, guys? Okay, then we'll see you tomorrow. Yeah, the questions are amazing. Keep going. Yeah, we'll learn together.